Hello students, welcome to this lecture number 7 on chemical bonding and atomic structure and molecular structures. In this lecture we will be going to discuss as reference to our previous lecture. We have discussed about how covalent bond become a polar characteristics. In this lecture, we will discuss the reverse of that ionic bonds has acquired some percentage of the covalent character. An ionic compound, it is considered as 100% ionic, but it has some percentage of the covalent character in it. As in the same way that we have observed in our previous lecture, that the covalent compound have the ionic character, polar character. So how this ionic bond becomes a covalent characters, how it achieves this covalent character in the ionic bond. For this, let us take the ionic compound. This is an ionic compound, and we know ionic compound have two different species, that is, one is cation and another is anion. It happens when cation approaches the anion, what is going to happen? It will distort some electron crowd of this anions towards itself, and it will looks like this. It will looks like this, that the charge, negative charge, have come to the positive cation and it will neutralize some portion of the positive charge, and in this way it will acquire some covalent characters. In the covalent bond, we can see the electron crowd in between the two atoms, and similar way you can see here the electron charge has been resided in between the two cations, between the cations and anions, and in this way there is a covalent character in the ionic compound, in the ionic bond. So here one thing that we need to understand, that when the cation has distorted the electron cloud from the anions, this effect is called the polarization, and power of the cation to polarize the positive charge of the negative charge of the anion is called the polarizing power. So we can write a very important thing, that is polarizing power. Polarizing power, it is the power of the cation. It is the power of cation to distort, to polarize, we can say, to polarize the negative charge, negative electron cloud, negative charge of anion. So it is called the polarizing power of the cation. And another thing that you need to understand, that is the polarizability. Polarizability. What is polarizability? Polarizability is basically the tendency of the anion to get polarized. So you can write, it is a tendency, it is the tendency of anion to get polarized. By cation. Obviously, the cation cation is going to polarize the negative charge towards itself, and in this process what is going to happen, there will be the neutralization of the positive charge of the cation, and higher the neutralization means higher the percentage of the covalent character has been imparted in the ionic bond. So we can understand how the ionic bond acquired some percentage of the covalent character in it. It is basically the distortion by the cation that it will distort the electronic charge, electron cloud around the negative ions. So that is the anions. So it is the distortion of the anions that is going to impact on the covalent character of the ionic bond. And in this process, when there is a distortion of the electronic charge by the cation, in this process the property of the compound also be changed. From the ionic property, ionic compound has some specific property and it will be changed to the covalent character property, and its melting point, its solubility and other properties that is going to be impacted with this effect. Okay, and there is some rules by which we can able to understand the covalent character in the ionic compound, and that is, these rules is called the Fajan's rule that we are going to discuss. The factors govern the covalent character in ionic bond. There are basically 2-3 factors. Number one factor, that is the size of the cation. Size of cation or anion. Cation or anion. How this size is going to influence? Number one, the size of cation. When the size of the cation is less size of cation, less size of cation, have the higher polarizing power, okay, higher polarizing power. As for example, you can see from this example that the LiCl have covalent character is much more than the KCl, because the lithium has a smaller size than the potassium, and that is why it will have the higher covalent character. Second thing, that the size of the anion. Size of anion going to influence. Let us first understand. If the size of the anion is higher, means its polarizability, tendency to polarize will be higher. At that time, it will have the higher covalent character in the ionic bond. So in this process, we can see this lithium iodide is much more covalent than the lithium chloride. Lithium chloride again much more having the covalent character in this ionic bond than lithium bromide, then lithium chloride, and then lithium fluoride. So as we goes the covalent character goes on decreasing because the ionic size goes on decreasing. So higher the covalent size, higher the size of the anions. You can say higher the size of the anions means higher will be its covalent character, and that we can see from here. And you can also see that its melting point have the reverse state. Melting point of this lithium iodide, it is coming around 440 degrees Celsius, and this is having here about 543 degrees Celsius, and it is about 610 degrees, and it is 870 degrees Celsius. So in this way you can see the melting point of this compound goes on increasing as its ionic percentage has been in the bond is increasing. Covalent character, as the covalent character is increasing, then you can see that they decreasing in the melting point, and that is how the property of the compound changes. Okay, now there is another very important factor, that is the charge of the cations or anions, which is also going to influence the covalent character. Next point, the next factor that is going to influence the covalent character in ionic bond, that is the charge on the cation and anions. You can see the higher the charge, means higher is polarizing power. Higher is polarizing power. So we can see sodium chloride have less covalent character than the magnesium chloride. So we can write it will having the higher ionic character than the magnesium chloride, but in terms of covalent character it will have the less covalent character than magnesium chloride. And again, magnesium chloride has a less covalent character than the aluminum chloride. And same thing is applicable when the anions charge goes on increasing, and it will going to impact the covalent character in the ionic compounds. Second, this is the second factor, and third factor, the electronic configuration. In this factor, what we observe, for the same size and the same charge, there is the same charge and same size, same charge and same size. Same charge and same size when the cation have the CO2 noble gas configuration, that it is having the 18 electrons in the outermost shell, having the higher polarizing power as compared to the normal noble gas electronic configurations. As for example, sodium plus having the electronic configuration, you can see that is the valence shells electronic configurations, you can see it will having the 8 electrons because it is the neon core, and it has the 8 electrons, that you can, its electronic configuration will be like this.
right? This electronic configuration will be like this, and the valence shell will having the 8 electrons. But if you see the copper it will have in the valence shell, there will be the 18 electrons, copper plus the 18 electrons, and this will, you can see the having much more polarizing power. This called the pseudo noble gas configurations. Pseudo noble gas configurations, this is called. Because of this, it is having the 18 electrons. You can have the electronic configuration of Cu plus. You will find the outermost shell there is the 18 electrons, and these 18 electrons, due to these 18 electrons, it will have the higher polarizing power, and in this way it will have the covalent character of the CuCl, covalent character of CuCl and NaCl. If you compare, you will find it will have the higher covalent character than the NaCl. Due to this very important thing, the pseudo noble gas electronic configuration, it will have the 18 electrons in their outermost shell, as compared to the sodium, it will have only 8 electrons. So we have discussed that how ionic compound has been converted into the some percentage will have the covalent characters, and with this process the property of the compound has been changed. So that is all for today's lecture, and next lecture we will discuss some other important point, that is some theories that we are going to discuss, that is the valence shell electron pair repulsive theory. How from this theory we will be able to predict about the shape of the molecules. Thank you very much for watching. If you like this video, you can share to your friends. Thank you.